Okay, so now let's go ahead and actually solve some application problems with exponential growth and decay functions. So for these, I need to use those from the first video. So if it's growth, then it's going to be y equals a 1 plus r raised to the t. If it's decay, then it's going to be y equals a times 1 minus r to the t. So it's going to be two different functions that we're going to be using here. So number one, it says the inaugural attendance of an annual music festival is 150,000. The attendance Y increases by 8% each year. Write an exponential growth function that represents the attendance after t years. So first, I need to figure out whether it's growth or decay. This one actually tells us that it's growth, but I could have also have seen that because it's increasing. And so this is going to be growth, so I know my function here is y equals a 1 plus r to the t. But now I need to figure out what my a and my r is, because I already know I don't know my years because it says after t years. So my a is my starting amount. So I need to look to see what I started with. Well, it says that the attendance of the annual music festival is 150,000. So that is my a. I start with 150,000 at this music festival. Now I need to figure out my rate, and I see in the next sentence it says the attendance increases by 8% each year, and so that is my rate. However, to plug it into this, I can't keep that as a percent. I need to change that to a decimal, and so now I need to take this point and I need to move it backwards too, to make it into a decimal. And since I ran out of numbers here, I'm just going to fill that in with a 0. So 8% is the same thing as 0.08. Now that I have all of that information, I can plug that in. So I get y equals 150,000, 1 plus 0.08 to the t. And I'm just going to go ahead and add those numbers in there. And I get 1.08. Okay, now for part B, it says how many people will attend the festival in the 5th year? Round your answer to the nearest 1,000. Okay, so now it's actually telling us the time, so it's telling us that 5 years have passed. So now I'm going to use my function that I just created. But now instead of t, I'm going to put a 5 there. And now I can go ahead and plug that into my calculator. So I'm going to go ahead and go to Desmos and type that in. So I have 150,000 and then parentheses 1.008, and then I'm going to raise that to the 5th power. And I see I get this huge number. But this question is asking me to raise it to the nearest 1,000. So I'm going to go ahead and just write that down. So I had 220,399. But I want to raise it to the nearest, or round it to the nearest 1,000. So I'm going to go to the 1,000 place, which is right there. Look next door. It's a 3. It's not bigger than 5, so that means I stay the same. So this would be 220,000 people. Okay, let's try another example. Here it says you buy a car for $48,000 in 2018. If the value of the car depreciates at a rate of 8.25% each year, how much is your car worth in 2032? Okay, my first step is I need to figure out whether this is a growth or decay. So I'm looking for keywords. Keyword here I see is that it depreciates. And so that means it's going down, the value of the car. So that means this is a decay. So I know my function is going to be y equals a, instead of 1 plus r, it's going to be 1 minus r. But now I need to figure out what my A is, my R is, and my T. So A is my starting amount, so what does the car start at being worth? Well, it starts at $48,000. That's how much the car is when I buy it. Now I need to figure out my rate, and I see it's depreciating rate of 8.25%. Again, I need to change that to a decimal, so I'm going to take this decimal point and I'm going to move it backwards 2. And so I really get 0.0825. And then I need to figure out my time. So I bought the car in 2018, and I want to see how much the car is worth in 2032. So how many years has passed? Well, I can take 2032 minus 2018. And when I do that, I get 14. So now I can go ahead and plug all of that information into my function here. So instead of A, I have 48,000. Instead of R, I have 0.0825. Instead of T, I have 14. And now I'm going to go over Desmos and type all of that in. So I have 48,000 parentheses 1 minus 0.0825 close parentheses, and then I want to raise that to the 14th power. And so I get this huge number, but since this is dealing with money, I want to raise that, or I want to round it to the nearest hundredth. So when I go to the hundredth spot, that's at the 1. I look next door, 9, which is bigger than 5, so I'm going to round up. And so I get that my car is worth $14,378.92. Okay, this last example is a little bit different.